A positively charged particle of mass m, kinetic energy k, enters a vertical magnetic field B. What is the acceleration of the particle? Here it enters a vertical magnetic field means the angle between the magnetic field and velocity is 90 degree. So we have to find the acceleration. We know that force is equal to mass into acceleration. That means acceleration is force by mass. And here the particle goes in a magnetic field, it will experience a magnetic Lorentz force. So magnetic Lorentz force is Q into V cross B. If you write this in a form, Q into VB sine theta n cap, and here theta is 90 degrees, sine 90 is 1. So the magnitude of the force here is BQV. So the acceleration of the particle A equal to BQV by m. But here they have given only the kinetic energy, but they have not given the velocity. So we are supposed to write velocity in the form of kinetic energy. So we know that, so let's part this. So we know that kinetic energy K is half mv square, which means that 2k by m is v square. So v square is 2k by m, and from this v equal to root over 2k by m. We are substituting in place of v this root over 2k by m. So acceleration is bq by m into root over 2k by m. When you bring this mass inside, the acceleration is bq by m into, instead of writing mass m here, so I'll take this inside, 2k by m cube. So there are two things to it. See, the acceleration is bq root over 2k by m cube, and another thing from this thing, if you cross multiply mass here, what you get is ma equal to bq into root over 2k by m. That means the force acting on the charged particle is this. Based on this relation, force is inversely proportional to square root of the mass. If you know the kinetic energy, and you must know that force is inversely proportional to square root of the mass, then acceleration here is inversely proportional to 1 by square root of m cube, or in other words, a is inversely proportional to m power 3 by 2. So these are two important results which you should remember. One is, when the kinetic energy is known, force is inversely proportional to square root of mass, and acceleration is inversely proportional to square root of m by 2, provided you know the kinetic energy is constant or kinetic energy is known. Okay.